Hey, what do you know? I think it's going to work. Great. Well, thank you very much. It's been a very fine week. It's been great. So I've tried to put together something that would be useful to everybody, both who are here, people who are here, and also people who did not have the opportunity to be here. I should apologize in advance. I'm not going to basically relive the meeting with all of you. That if you're interested, of course, the whole program is here, and the abstract book also has most of the talks and contributions linked. So I've put that link there as well. And what I'm going to do is just pick and choose several topics, and I apologize for leaving things out. If I get anything wrong or left out a really important message that one of the organizers wants to add at the end, you, of course, invited, completely welcome. And I'd like to thank also the scribes who provided session summaries. And what I've done is actually copy and paste those at the back. So this talk is kind of one-stop shopping to go back to see what happened. And I'm trying not to rely on Slack or links, which will go away over the next year or two. I am not one for delayed gratification, at least when it comes to being grateful. And so I'd like to start off by thanking all the conference staff, all the workers at this wonderful venue, the session organizers, all the speakers and contributors. The local organizing committee obviously did a huge amount of work. It's when there aren't problems that you know there was really a large amount of work. And even when there were small snags, issues were resolved quickly. And that really says a lot. And that was not easy at all. And not just the local organizing committee, but the international scientific organizing committee as well. Here is a slide from Federica's talk at the beginning, thanking people, except Federica wasn't in her own slide. So I'm happy to add Federica here. And I think we should just pause and have a moment of gratitude and applause for all of these people who made the conference possible. I would like to start with some personal observations and context because it's on my mind, and talking at dinner and at coffee, I think it's on all of your minds as well. And we haven't had a chance to talk about it. And I think it's useful in summarizing our experience here. First is obviously the pandemic. This was postponed. We haven't been together in quite a while. This is the first big meeting for a lot of us. And it's a big deal. Every one of us and your friends and family and coworkers have stories about what has happened and the challenges of the pandemic. I think that we should acknowledge there were some silver linings also, but there were a lot of challenges. And we're here in Italy, and all of us around the world understood that the pandemic hit especially hard locally here in Italy. And we all watched and were thinking of you. And the fact that we're actually here, and Trastevere is noisy at night with life, with people celebrating, and maybe crowded in a little too much without masks, but still the fact that that's happening, I think we all knew intellectually we'd be getting back to that, but there were times where we really wondered. And so all of the crowds and maybe things that would annoy people once in a while are actually cause for celebration. And I think that's really important and just great that we could all be here. A lot happens when we all get together. The other thing is there's a war in Europe. And again, we all think about it, but I think it kind of does two things at the same time, at least for me. It makes the thing, when we worry about schedule and little details, or maybe a colleague who's behaving in a way that, who's thinking maybe needs a little bit of improvement, an international situation kind of pulls you back and maybe makes the things that we're worried about put it into perspective and maybe seem a little less important. On the other hand, I would argue that international science projects that have an enduring legacy also become more important in that context. The fact that we actually are working together and creating something and talk with each other and develop a common understanding is actually even more important in that context. And so I think that's really great. I also think it's really great that we recognize that problems elsewhere due to others' situations and behavior, we also understand we need to improve our own local situation. And I'm very glad that in this meeting we had the session that Alicia ran. I think that's part of the context, and I'll talk a little bit more about it. And then where we're actually meeting here in this fantastic venue really helps to put into an important context. If you go down to the library, there's a fairly old manuscript about Galileo, and it's very impressive. I believe it's gloves only. And it reminds us that Galileo was very likely the first person to apply a telescope or spyglass to make astronomical observations. And what was accomplished was amazing, and what it started was amazing. And then you fast forward to where we are and look at the Rubin Observatory, and you just think tens of billions of objects revisited more than 800 times, some 30 trillion observations times objects, and it is amazing what we accomplish when we work together. And of course, the legacy is, in my mind at least, direct. And again, here we are in Italy. The other thing reminded me actually during Michael Jones McKeon's talk, who is our artist in residence. If you are unable to attend that session, I recommend you have a look at it, and the video, I think it was recorded. I heard a talk by Nane Binyami where he showed, these aren't his images, but either replicas or images of Galileo's telescope. And the thing that I noticed at the time was how ornately it's decorated. And the people who built instruments were artisans. I think we are as well. But there was a certain pride and a connection to art and technology at that time that's a little different. Now we just slather teal paint all over the thing, which I love the teal. It's very nice. But there's a difference here that is worth noting and is interesting. And I think we'll learn a lot from each other, the artists in residence and us. And then our location, I'll get on to the sessions in a minute, don't worry. But the cultural crossroads, Trastevere is a fantastic place. There's a lot going on. I was quite surprised, although this wasn't in the dark energy science collaboration session. There on the street in Trastevere was a sign about baryon acoustic oscillations. And sorry for the cheesy joke. But seeing these things right next to each other was quite interesting. More seriously, if you leave the building and turn right and walk about 6 minutes, you come upon this artwork that I recommend to you. It's a statue or a sculpture of a homeless person. And then you look at it for a while and you notice some things which I'll let that sink in for you if you look at this picture. That I found quite moving personally, and that's in the Piazza di San Egidio. And of course, the Accademia dei Lincei is fantastic. I'm happy to give credit to Dragana Illich for this great picture of a sunrise on the first day. You just walk around and it's a very inspiring place and a very, very interesting place. Okay, so let's get back to the program. I think appropriately, everything started with a talk by Beth Willman about the LSSTC. given the way in which the effort worldwide on Rubin Observatory is factorized, it's very helpful to have a kind of scientific organization that supports cross-cutting science and helps with networking. And of course, they do so much more than that. They help to support the culture as well. And so there was a great summary by Beth, who's the new CEO and Director for Science of the LSSTC. And if you didn't hear her talk, I recommend that. Very, very important. And then we had a lot of Rubin project sessions, and there were talks on the status, commissioning, Oxtel, data processing, early science. We just heard the talk from Federica on observing strategy, and there was a lot of great information. But I think even more important are interactions at coffee and in Q&A. There were a lot of great ideas suggested. We're already at work on a bunch of them. And I would just say as strongly as I can, the community feedback and all the suggestions that were made during the meeting, and actually every week on all our telecons, they're really much appreciated. Please keep them coming. And then, of course, there are essential European contributions to Rubin and LSST. We just heard a great train of talks this morning. It's threaded throughout all of the rest of this presentation and the meeting. One thing we didn't show that I thought I would take a time to show is on the hardware. On the camera, there are actually quite a lot of European contributions. Here's a great video of the filter exchange system. So the filters live on a carousel. 5 filters are stored around inside the camera body here. And then we can give a command to change a filter, and that filter exchange system, the actual hardware that moves the filter from a carousel, can be seen here. Here, of course, is the focal plane with all the science sensors, and you're looking at it through the L1 lens. By the way, the broadband AR coatings were produced by a company in France. Our colleagues in France made this filter exchange system and made it work within the 90-second exchange time, which is absolutely amazing, and it was a huge amount of work by itself. And we also have lots of expertise from the UK working with us on sensors and on and on. But it's fun to see a kind of 75 centimeter clear aperture piece of glass get moved. There's a little bit of a delay here, but here's the filter coming down, and this isn't even running necessarily at full speed, but it just gives you a feeling for what's going on. And it's a little different if you look at it on your little computer screen versus something approximating real life size. It's very impressive. And of course, these are precious cargo that we want to take careful note of. But I would just use this opportunity to remind, we had a great talk about gravitational wave follow-up, and to remind people that in any one night, we will typically have 5 of the 6 filters on board and easily exchangeable. And then it's during the day that we would swap one filter out for another based on what the survey and the scheduler have planned. Okay. So synergies, a lot. There was a huge amount at this meeting. SKA, I mentioned already, gravitational wave follow-up, and the unique capabilities of the wide field of view and sensitivity that we have with Rubin. So that was very, I think, very helpful and inspiring talk, and was very, very helpful. CTA, very high energy gamma rays from the ground. There are synergies there, actually numerous synergies. Gaia, obviously, you heard a little bit about Euclid. I'll mention that in just a minute. And of course, ESO, ELT. There are a lot of synergies, and they're really important because, of course, the objects that we're studying don't care what wavelength we call them, and the energy that they put out can be multi-messenger, and so it's on us to to combine information that's just coming to us, and we need to make use of it. One sort of odd thing I would say is that there was no talk about Nancy Grace Roman's synergy at this meeting. And since we're in Rome and there are no Romans here, I thought that was sort of interesting. And maybe that's something to think about the next meeting. I know the project scientist, Julie McHenry, is very interested in synergies. And so that might be food for thought for the next time. So speaking of Euclid, I think we all saw this slide or a slide like it about the strategy and next steps related to the process that happened to identify mutually beneficial data products. There was a session led by Nicole and Leanne, and there's a document there that's right up on the archive that talks about the derived data products and what can be done and what the value is. There is an issue that the joint processing is not resourced right now, and so that's something that needs attention. There is, of course, both observatories have their own pipelines, and there will be source exchange already set in DDP CC1, envisioned in the document. And so that enables early source sharing, but the bigger goal is to work toward a joint processing, the pixel level, to do multi-band deblended photometry. Here's a little plot just showing for brighter, well, not brighter, but depth limited maybe, Euclid galaxies, and for the subset where we will have a good measurement with Rubin, meaning signal noise greater than 5, those are the green, that's the green subsample, and that's where all of this would apply. And so there has to be a path forward to quantify and find the effort to produce all of the derived data products, and that's in work. Science collaborations. So there was a great introduction by Will Clarkson. So I recommend that if you missed it. It tells you what all the science collaborations are up to just on kind of one chart summary, which of course is simplistic, but is a good introductory and overview. I'm not going to do that again here. Okay, I'm going to focus on the things that were discussed here. So please have a look. If you have trouble decoding the acronyms like SMWLV or DES desk or ISSC, you can find that here if you don't already know them. I suspect most of you do. There are some really interesting slides about the demographics of the collaborations where there are people around the world. And very importantly, I think in this slide here, it shows all of the interfaces and how the science collaborations, which are, formally independent, also have points of contact with various aspects of the project, and how the standing committees, what standing committees there are to kind of fill in the interstices. And so this is a good place to kind of look to see how things are laid out. I'm looking at this now thinking that this is an unfortunate kind of spike protein picture, but it was made before then, I believe. So, all right, so getting on to the various science collaborations. Let me just apologize again that I'm not going to be able to cover everything. I just did a pick and choose of things that I thought were interesting at the kind of summary level here. And I would stress again that the summaries by the scribes are also appended, but that's a lot of text to go through here. So Mario and Meg organized a great session. They were all great sessions on solar system science. And you can see the talks that were in this particular meeting here, as well as there was an overview of what the challenges are and the opportunities. I'd remind you that a lot of the science happens in the first year or two. And the value of getting together is, I think, displayed here when after the session in discussions, there was an opportunity for improvement that was identified, and that is for imminent impactors, small objects that will collide with the Earth within hours to days. So these are relatively small. They're not really threatening us. There's a back of the envelope estimate that there would be a few of these per year by Rubin. They're kind of meter size objects. There have been 5 since 2008 that are known, and then you just scale again back in the envelope, small envelope, you get to a few per year for Rubin. And this is interesting for rehearsing or understanding planetary defense aspects, but also for composition studies. It's useful to know where the thing's going to hit in advance, and for that you need a good, set of ephemerides to be able to do that sufficiently precisely. And what people realized was it would be useful to kind of pre-cover sub threshold information from previous observations. These are presumably streakers, and they may be at 4 sigma, for example, in the earlier images, and being able to go back and look at those and then use that as a lever arm to predict, to use the most recent images to together with the most recent images to predict the path would be a useful thing. We do have this issue that we don't routinely release image data till 80 hours after our observations. That's not, I'm not talking about the prompt data products, talking about just the full images. And so we need to look at this to understand the expected value of these objects and ways of making exceptional case LSST data available, at least to be able to find the impact location, possibly internally, to enable studies of imminent impactors. So this is the kind of thing that you just realize after getting together, and I think it's an interesting thing. So thanks to the Solar System Science Collaboration and the people who went to that meeting for uncovering that. That will be a topic of discussion. So Dark Energy Science Collaboration desk, there was a lot here as well. There's an idea of just taking the pixels and using a convolutional neural net to identify galaxy clusters, to detect and identify galaxy clusters. There were some very interesting results there. Similarly, to use machine learning, but incorporating the host galaxy information to improve the real-time detection of supernovae. That's shown here. And there are some possible and interesting correlations between galaxy properties and galaxy clustering, in other words, biases that could be that are being looked at. So that's really good. The other thing is there's this internally, the desk has many different methods for extracting cosmological parameters. And it's the combination of those parameters where we actually win, because you can think of the error surface in hyperspace being some complicated thing for each method, and where they intersect and overlap, that's a way to get better measurements, but also to uncover systematic errors or wrong assumptions or new physics. And so the desk is hard at work on that in this new kind of process internally. They are very interested in links to other collaborations, strong lensing, for example. There are connections you'll see. And of course, they're wide open, as all the science groups are, for more collaboration. Galaxies, well, they're dusty places. And there's a lot of challenge for being able to understand that in context for making measurements. And there were some interesting ideas here for using LSST data alone to be able to infer properties. So that was interesting. And one of the other things that kind of had a moment at this meeting was surface brightness fluctuations. I think it was Ed Ajar who said that Rubin will be an SBF machine. And is there a problem with that? Oh, did it not change? Okay, thank you. The challenge here, and I'll make this point later on, I mean, it's one thing to do this sort of thing on one or two images, but how do you combine a large number of visits, the information from a large number of individual images in order to extract something like this? And you can naively think you could do it on the coads, but it's something that needs to be demonstrated. And this is a theme which I think we all understand, which is that great new data are not just about applying the old analyses and then you get a better result because the data are better. You need a new approach, you need to rethink how we actually use the data. And this is a really interesting example, I think. And so that was interesting. It was also interesting to see this come up in multiple breakout sessions. So that was great. TVS, again, I'm just showing the agenda. I can't go through it all, but there, again, there was this talk, or this, was it a talk or posted by Nandini on again, just trying to do some automated processing in order to handle the large amount of data that we're going to have on a very large number of galaxies in order to get, to infer distances. And that's, I think it's really, really interesting work. Supernovae, of course, are always of great interest. I was very interested to see that there's this whole subgroup working on data visualization within TVS. And I think that's another opportunity for cross collaboration, cooperation. Certainly knowing what we're all doing is going to be really great, and being able to grab and build upon the work. There's no question this is going to be extremely useful. So I recommend that you check that out. It's also a good opportunity to think about accessibility. And then, of course, something that figured heavily in all of the sessions, or most of the sessions, was the SCOC work. All of the science collaborations have representatives there, and that's really great because that's how we get to the right answer. I'll say a few words about one data set serving all the science that I think is important. AGN, so I think you all know there are different kinds of AGN. We think that a blazar has a supermassive black hole, probably maximally spinning at the center, and there's stuff accreting onto it, and through some combination of general relativity and magnetohydrodynamics, some of that energy, either from the infall or the rotation itself, can be extracted, and very collimated jets are organized. Multi-TeV particles particles can be accelerated multi-TeV energies, and that jet stays organized to well outside the galaxy itself. It's absolutely stunning. And the amount of power is just, incredibly interesting. And the different phenomenology may, and again, this is something subject to, probably to some extent at least, has to do with what the orientation is with respect to us. If you're a few degrees off with respect to the jet axis and observing, if that happens to point to the Earth, you're going to see very high energy gamma rays from inverse Compton scattering. It's so interesting to me, actually, that neighboring bands in the electromagnetic spectrum don't often have as much to do with each other as you might think because of these mechanisms. So for example, radio and gamma ray have more to do with each other than X-ray and gamma ray. The X-rays are probably coming from the hot disk, and the gamma rays are coming from inverse Compton scattering. And of course, optical variability is extremely important, getting back to Rubin. And so there was a whole discussion about blazar variability, but also um, about AGN population studies. And I think it's also really interesting, and of course it's been in the science book since the beginning, about looking for the highest redshift AGN. They're bright. We should be able to see them if they're there at a redshift of 6 or even 7. And the question is, how'd they get there? That is interesting. And of course, theorists will always find a way, but it's a really interesting question. And I would suggest just stepping back a minute. AGN are beautiful. I know myself, I've worked on them. You can get mollified by beautiful things, and it's important to ask, what are we learning about them? Why are we studying them? What is the actual goal? It's not just characterization. We want to understand these mechanisms. And so we should always remind ourselves that that's really what we're after. The meaning behind the data is what we need. And of course, that involves theory and modeling. And that's extremely important. That's as important as data analysis and operations, is to have theorists funded well in order to help us get meaning from the data. And of course, the AGN science collaboration is looking forward to great opportunities, not just in 2023, but in the future, and the doors, open there. Oh, the other thing that was quite interesting was a presentation by Raphael Shirley about Vista, which is kind of about 10 hours drive north of Pachon, and it's a 4-meter class telescope, so they see, it's not as deep, but they're, if I understand correctly, actually running instance of the Rubin pipeline, and also very interested in being able to share those observations in narrow bands. So that's the interest, and to be able to do kind of pixel level comparisons with LSST data, and they're making those data available on the UK DAC. So it's an interesting question to me, what ancillary data is going to be only at one data access center versus others, and how we're going to move freely among the data access centers, assuming that we have data rights. I know that from personal experience, that credential verification on even one data facility is already hard enough. And so making that, we might need an edgerome of data access centers or something equivalent. And if I stepped on somebody's toes, I apologize. I'm just interested in getting the data. Okay, strong lensing. So there was a lot discussed about the pipeline, the discovery pipeline, which again is something that really crosses science areas. So cluster lens supernovae, very interesting from the point of view of Hubble parameter extraction. And there were some interesting, again, of course, everyone is doing machine learning approaches to finding and analyzing gravitational lenses. And the ultimate here is to combine gravitational wave transients and lensing together to look for lensed gravitational waves. And there was a very interesting presentation on that. And again, that group is very interested in intercollaboration agreements, because even if you're not so interested in the lensing technique, it might affect your science. And so there's a lot, again, that we can learn from each other. Okay, stars, Milky Way, local volume. So there's a lot of work done on just simulations to make catalogs of stars. And this is a bootstrap kind of process, or an iterative process, where more and more fidelity, and I would say richness in phenomenology is being added. And again, this could be something of a lot of interest to other groups interested in science involving Milky Way and who happen maybe not to be working in this particular group. And so that was extremely interesting as well. I mean, all of it is extremely interesting. Low surface brightness. So this is also an area that Rubin, it's been understood for a very long time that LSST data are a great opportunity. For various aspects, of course, interested in dwarfs and other related halo objects. There's a talk about intra-cluster light that could be good relic information about the assembly of clusters. And of course, the precision of our knowledge of clusters has a big impact on a lot of different science, including dark energy science. And so everything from satellites to clusters are related to low surface brightness science. And the interesting thing here is that calibration is critical, and understanding the night sky subtraction is critical. So it's all about the systematics at the edge of our capabilities. ISSC is a fantastic crossroads because each group is using machine learning to some extent, and statistics are going to be absolutely essential because it's not the values that we measure, but the errors that are going to matter for all of our science, and that's where things are going to get particularly hard. And so it's a great place to involve each of the science groups to come to those discussions. And it's great that there's an ISSC science collaboration devoted to that. It's going to be very useful. Okay, so that's a quick tour. I had hoped to drop in our group photo, but I haven't seen it yet. So here's here's a picture I took yesterday in next door. It kind of makes me think about meetings and parallel sessions and so on. So. Okay, we heard a great talk about the in-kind program, great overview, Aprajita, and again, it is something that ties us all together, and it is a challenge because each person brings some different perspective. And sometimes people are not funded. A lot of times people are not funded for that work. And yet it's really the way we're going to get there and to get our science out. And so that's quite useful. In-kind processes are key, obviously, and will be taking a lot of attention and will be a huge benefit. And then processes in kindness and fixing our culture are also extremely important. And I think the session led by Alicia was great. I've put here a summary from that workshop. I would like to add, in addition to everything that was discussed, is that shaming seldom works. In fact, I don't know of a good instance where making someone feel ashamed was actually beneficial and changed behavior and was effective, and instead it was just damaging. And so I think we need to be very careful. Each of us will make a mistake from time to time, and we need to practice better how to have these interventions, I suggest. And role-playing is not a bad idea, where we actually kind of rehearse or revisit something that's happened, where we actually talk through an event, because those are typically high stress, high emotion moments. And we don't have the training for that, how to handle that. And I think that in addition to this discussion, which was relatively comfortable, we should get a little more uncomfortable and actually together build trust. I think that's the other thing to watch, which is benefit of the doubt. If behavior becomes an enduring problem, then it erodes benefit of the doubt, and you don't actually get anywhere in a collaboration once benefit of the doubt goes away. And so I would suggest we need to monitor that. And grab that back and rebuild that. And I think this is a way to do it, to actually have a, a lower stakes conversation. All right, we already heard this great report from all the work the SCOC is doing. As you understood, this is not easy. But I want to finish up here, and I'm going to go a little out of order, which is, it's true that it's a challenge for doing optimization of the overall survey, but this one data set serving all the science is a fantastic opportunity. And I think we all understand that. I think you all understand it. And the additional advantages are not always apparent once you get used to this whole way of doing things, where you don't have to argue about where to point, and you don't have to worry about one area of science getting proprietary data that to the detriment of another area of science. Everybody just gets everything. The cultural differences among communities are noticeable in these discussions, but they're not necessarily impediments. In fact, I think they're reinforcing capabilities, and they enable important new opportunities. And so I'm not trying to make a greeting card statement, but we are lucky to have each other. And it's important to step back and understand that at moments where things can be a little bit tense. The other thing is, for early career colleagues, and actually people who are looking to move to other areas, crossing subfields gets a lot easier. You sit at the RSP and you've got data that serves a huge amount of science. And if you're interested in somebody else's science or some other area, you just start doing it. And those kinds of shared tools and data are something that only typically happen when one data set is there to serve all of the science. I've seen this work. It's really great. I appreciate how difficult it is also, but again, we're all going to benefit from working this way together. Those great leaps in capabilities have very broad impacts. They will certainly affect science even far beyond Rubin, and I already made this point, but great leaps in measurement capabilities demand new analysis approaches. It's not just doing the same old analyses better. I will say that just as a reminder, I wasn't sure whether Chris's talk was going to happen. Citizen science opportunities can be extremely important, and Rubin data are a very interesting possibility. And the idea is not to think about it as outreach, but as science opportunity. The way to engage people who want to do work, who want to help. There are ways to do this, and to add more eyes. Machine learning, of course, tagged machine learning is, supervised machine learning is one obvious possibility, but there are all kinds of applications. If you haven't looked at Zooniverse, I recommend it. And that may be something, most of us are not trained and don't have a lot of experience with citizen science. And so having it put in front of us to reimagine possibilities is a good thing to do. The slide just changed. Wow. Oh, okay. Okay. All right, good. The other thing, obviously, I'll just say, because I like saying it, which is that Rubin LSST would just not be possible without great international and multicultural cooperation. It is intrinsic, and we wouldn't be here without it. So I'll just close by saying it's a fantastic time. We have a hell of a lot of work to do. But there's just so much great data and new results coming quite soon. I mean, this is when it really gets real and is very exciting. So thank you very much. And I'll just say that I've got the session scribe summaries, pages and pages of them. Here you can go to your favorite group or the one you want to look at. And many thanks to the people who put the time into this. I did grab information from them to pull forward as points, but I couldn't possibly cover it all. So I just put it here. You're not going to have to dig it out of Slack or anything. It's there for you.
Thank you, Steve. That was hugely inspiring. Thank you for talking about things that we had not addressed, such as the pandemic and its impact in Italy and the war. We do want to be conscious at all times of that and think about compassionately about each other's experience about that. So I wanted to personally thank you about this, and maybe let's all thank Steve again for touching on this.